Hello everyone, welcome back to the Loco Builder. We're continuing on with this DJH A1 and today we're going to be looking at the construction of the tender. In front of you, you can see most of the bits that we actually need, and I've already taken time to prepare most of the parts. And for example here, where we've got slot and tab construction, this is the base plate for the tender here. All you need to do is just open up these slots, because the chances are that the tabs will be a bit too tight to fit in just due to the way that it's etched. So just get your scalpel in there and just open up the slots so that we can fit the tabs inside nice and easily, and then just clean up as we do with all the other bits and pieces. The other main component of the tender is this casting which goes on top, and actually it's not a particularly good casting. I hope you can see there, but there's quite a lot of pitting just in here, and also the feed nibs on this side here were particularly difficult to remove, so I just need to fill those. There's also a couple of bits of beading that have got damaged there as well, so later on I'll show you how to reinstate that. That's not a problem, but this should be a fairly straightforward build, and because the vast majority of it's brass, it should go together nice and easily. Right, we'll kick off with the chassis itself then. As always, the procedure for soldering brass is exactly the same. All we want to do is get in there with the glass fibre brush here and just clean up the edges where we're actually going to do our soldering, just like that, to make sure that what we're soldering is nice and clean. You can't solder if it's not nice and clean, it just doesn't happen. I've got my soldering iron set to 380 degrees Celsius. I'm using standard phosphoric acid flux. I've just blue tacked that down onto my workbench because the amount of flux I've spilt is probably more than I've actually used in my entire model making career, so always secure your flux onto the work surface, and then we go in with some flux like so, and just flux along all of these joints. I've just bent up the various bits on there, as you can see, so plenty of flux. Clean the tip of the iron and just carry some of the solder onto the piece and then just run in like that. Just repeat on both sides, and then that's the first stage done. That just strengthens up these right angle joints here and ensures that the tender's not going to move about and distort. The next stage is to add some frame spacers to the chassis, and for that we need to fix some captive nuts onto the spacers themselves. It's quite easy to do. All we need is our frame spacer and an 8/8 nut, which we've already cleaned up, and all we simply do is just work out what side the nut goes onto, so it's this side in this case. Put the spacer onto a cocktail stick and then screw the nut over the cocktail stick like that, and then just let it hang down. I'm using 180 solder for this because I don't want these nuts to work themselves loose when we actually attach the spacer onto the chassis. So 180 solder, the iron is still on at 380. So in with some flux, grab the iron, clean off the end like so, and then add a good amount of solder and just let it flow around like that. Give it a moment to solidify. Ow, hot. Unscrew the cocktail stick, and then that should have protected most of it, but then to make sure that the screw thread is nice and clear, we just use this, which is an 8/8 tap, and we simply put that on the top like so, and then just start gently turning like that, just to clear out that screw thread. And if it's a bit hard going because it's a small piece of metal, simply use your pliers to clear the hole, and I can feel now that that is nice and clear. Make sure it's all the way through. There we are. Unscrew, and that means that your soldering's good because the nut hasn't fallen off. Quick clean with the glass fibre brush, and then the proof of the pudding, of course, is where the 8BA nut goes into it, and I can just do that up with my fingers nice and easily. So that's the captive nut added to the frame spacer. Next, I'll fit the spacer plates onto the chassis itself. So just again, in with the flux. And I'm now going to use the 145 solder instead. There's plenty of flux on all of those. And you can see now the reason that I use the 180 solder is because I'm soldering quite close to where those keeper nuts were placed. So here we go, in with the, in with the 145 solder. Just very quick in and out with the iron. You don't need to dwell with it. It's just to make, you can see that the solder comes through on that side anyway. It's just to make a nice strong joint. You can see solder coming through on all of those joints there, so they're all nice and secure. And now the chassis is starting to gain its strength and take shape. Now we need to get the wheels set to the correct back-to-back. I've painted already the wheels like so, and these are the correct spoked variety that we need. And in order to protect the wheels from the chassis and make sure that we don't get any shorts, I've got these 2mm fibre washers, and I picked up about 5,000 of these from eBay for about £3 or something like that, and I've probably got enough there to last me 2 lifetimes of logo building. So first of all, just put on a couple of the washers onto the axle like so, and then grab your other wheel, just ease it onto the axle like so. And then I've got my back-to-back gauge here, and this is actually a fine scale back-to-back for 00, so that means it's slightly wider, and you can use it with fine scale wheel sets like these, and it just gives you better running through fine scale track. It still works through your normal Pico and Hornby track as well with the back-to-back set in this manner, but it just gives slightly better running on fine scale track. So I now just put these washers into the middle like that, pop the axle onto the back-to-back gauge and just press through from the top like that. And that's not too bad actually, it's probably a bit tight, so I'm just going to ease it ever so slightly, and that just drops on there beautifully. And that's now the back-to-back correctly set, and it means that the tender should run through point work very nicely. If you find that you have some stock that derails on a particular portion of track or that derails through points, the first thing to do is check the back-to-back. Get yourself a back-to-back gauge, either 00 fine scale, EM, P4, whatever it is you use, or just a standard 00 back-to-back gauge. That is often the problem. Sometimes wheel sets move out of alignment, so just give them a check. I'll just get the other ones done, and then we can test the chassis around the corners. Now's actually a good time to check the chassis work, so we'll just put these axles into the chassis, and they just rest in these little cutouts like so. Just make sure the washers are on the outsides like so, and then we just put this keeper plate on the top, and DJH actually put a little arrow there to signify the front, so we'll just get it the right way around and then screw it in. Now then, in order to test this, I've got a piece of, I think this is third radius set track or something like that. Anyway, put that on there, and hey presto, it goes along there beautifully. Now this is much tighter than anything I'll use on my layout. I'm probably going to use 3 foot radius minimum, so I've got no idea what this radius is, but it's pretty tight, isn't it? But anyway, chassis runs really nicely, lovely and smooth. Happy days. Alright, we're now in a position to fit the brake shoes, which are these little bits here. And they just need bending up. They come in flat sections like this, so just grab a pair of flat pliers and simply bend them up into the correct shape, just ensuring they're at 90 degrees. And then they can be attached to the model, which I'll show you in a sec. However, I just want to show you a little problem that I encountered. I already soldered up the back of this, so it was at a right angle. However, I couldn't get then the rear brake shoes in because they come combined with guard irons. So in order to get these to slot in like that, I had to just desolder the back plate there in order to get this bit to fit. However, there's a further problem in that once that's folded up and it touches the rear guard irons, I'm not actually able to get these replacement buffers in because they protrude too far out of the back. So what I might do is just cut these buffers off, just cut these guard irons off just at the top there. Hope you can see that. Just at the top, in there, and then just solder them onto the back of this plate once I've got the buffers attached and these are out of the way, so that would be an easier way to go about that. But anyway, let's get these, we'll get one of these, I cleaned one up, where is it? I don't know. Anyway, we'll clean one up now. Let's do that. So here's one of these. I just checked to make sure that I can actually get the wheels in place once these brake shoes are on, and it seems I can. So this is actually turning out to be a very well designed tender by DJH. Actually, I'm very impressed with this so far. So just slot that into the correct place like that. Flux on both sides. I'm just going to pick up some 145 solder. Where's it gone? Here it is. A little bit of 145 solder there. Make sure it's level. And simply solder in like that. And there's my little brake shoes in place, and you can see that it's quite easy to refit the wheels. There we are, and there's no fouling on those brake shoes, so I'll get the rest of those on now. So now we need to fit the pull rods onto the brake hangers themselves. I've just soldered on these little cross members here. That's just 1/2 mil wire, and I've just brought you in a bit closer so you can see what I'm actually doing here. What we want is probably about 1 mil or so of clearance between the edge of the wheel and the pull rod itself when the wheel's at its sort of greatest extent of travel, if you like. So the width is, so you can just see there's about just 1 mil or so, and that just enables the wheel to move without it shorting on the brake rod at all there. So there should be no chance of that moving, so I can just go ahead and solder just on there like that. Just tack that in initially. Just a little bit of small amount of 145 solder on there. There we are. And now I can remove, in fact now I'll leave them in, and I will do the other side. So now that's tacked in place on both sides. I'll get rid of the wheels. There we are. And I can just check the alignment, make sure everything is straight, and I'll solder the rest of the edges on and trim off the ends of the protruding rod there. The next job then is to form the tender sides from this piece of brass here. I've already formed the flares on both ends, as you can see there, and I've already done one of the corners. Now what you need to do with this is that you can already see that there's some half etched lines in there which help you to bend the material, but what I've done, because they weren't fully etched on mine, I just used a small file, quite a sharp square file or a triangular file, and a scriber just to open up those lines a little bit and to make the bending process easier. So what we need to do essentially is, using the handle of that file like that, just press it down on a hard surface and put it in about the midpoint of the etched lines there, and all we want to do is grab the end of the piece of brass and then just start to slowly bend it up just like that, all the while pressing down on the file. You can use both hands. Just make sure that the bend that you're creating is parallel, and then bend it up slightly over, and then we can have a look and see how we're going with that. Now that's not too bad, that first bend there. Let's just get the tender and see how it actually fits. Try and get that in the middle for you so you can see. Okay, so what I can see there is that I'm good on this side, but on this side I'm slightly out, so I just need to bring that bend in ever so slightly. And so, try and show you this. What I'll probably do is just grab these pliers and just tease the bend in a little bit, like this. Sort of forming it with my fingers as well there, and then I can bend this bit out a little bit just to try and sort of tighten up the bend. It is a little bit of a tricky process, as you can see, to try and get this right. You don't always get it first time. And now we can see that by using the top of the tender as a guide, we're now starting to get there. I've just tightened up that bend just a little bit. And now we pretty much have, apart from that tab not quite fitting, a fully aligned and bent up tender side. Right, we're now in a position to solder the sides of the tender onto the foot plate. I've just fettled the corners here just with a sanding stick, just like so, just to round off those and make the edges nice and smooth. And the way that we solder the side of the tender to the foot plate is by initially tacking the joint together. So what we do is just hold it like that. I've got the iron on at 380, so it's quite warm. Get a blob of solder, hold the tender sides in the correct place, and then just go in with the solder and make basically what's called a tack joint. like that. It doesn't need to be a good joint. All it needs to do is to hold the piece of metal in, because we'll go back later on and solder it all up properly. But all that does, it just holds it in place. Now, we check that everything is level and looking relatively square. And we make another tack joint here, away from the first one. There we are. You can start to see that's looking quite good. And then we also do this side as well. This one's a bit trickier. I'll just see if I can, there we go, hold that in place like that. And hopefully you can see when I solder that. There we go, in with the flux. Blob of solder. And just flash in with the iron like that. So now this is joined up, we can start to check whether everything's level and square. But just using my little set square here. And of course the other check that we can do is just put the tender top on, and you can see right the way round that it's essentially perfect fit, which means we've got the alignment spot on. Now we go back inside and solder all the way around the edge, joining up all the tack joints that we made. We'll make a few more. So let's do one in there like that. Now these are not great solder joints at the moment, but all they're doing is holding everything in place. And then what I'll do is, once all of this is securely tacked in place, I'll run around with the soldering iron once more, fill in the gaps and make sure we've got a lovely neat seam. You can see now that we've finished off soldering the sides onto the base of the tender, and we've got a lovely neat ring of solder all the way around the edge of that. I've also secured this front bulkhead as well, just to secure everything, and the test really is whether the top fits properly on here, and I hope that you can see that it fits very, very nicely indeed, and that means that we've got things just about right. I cleaned up the edge of this just using this graver, which is a tool that some of you have asked about before. It's about 2.5 mil square, it's got a very sharp beveled edge on it, and I can just run that along the side of the panel. And it just helps me to clean up any excess solder that's flowing out and making a sort of ridge on the model itself. So that's a very useful tool. That's a graver, so very useful indeed for cleaning up. I'll go ahead now and add all the detail into the inside of this, so it'll be all soldered in from the inside. There's nothing new there that you haven't seen before, and then I'll show you how to attach this white metal lid onto the tender sides. Alright then, well, I said earlier that I'd show you how to make repairs to white metal should you need to, and we can just see here on the edge of the beading there where my finger is that we've taken a little chunk out of the tender top there. So there's no need to chuck it out the window, we can repair it quite easily. That's the beauty of working with metal. The first thing to do, I like to just square up the gap in the beading with a small square file, just like so, and then we just clean it off with a glass fibre brush just to make sure that the area is nice and clean. Now we've set our iron to 180, which is the absolute lowest that mine can go, and I'm just going to add a small amount of flux onto the area there, and this is a slightly different technique with our soldering. We're not looking to necessarily have the solder flow everywhere, we want to make kind of like a blob. So I'm picking up a reasonable amount of low melt solder onto the tip of the soldering iron, and I'm just going to kind of swipe it across the joint, the sort of gap there, and try and make it a blob of solder, if you like, if you see what I mean. So I'm just building it up. I'm just going to let it cool down there, and you can just see that I'm starting to build up a little blob. And what we don't want to do is kind of destroy the solder that we've already put there. So pick up a bit more low melt solder. I'm going to use the kind of tip of the little bit of solder that's coming out there and sort of dab it on, just like that. There we are. And I've built up, I hope you can see, I've built up a little ridge of solder, and we can now start to dress that back and replace the lost beading. I'm going to start off with a small flat fine file. We don't want to use a big file on this because we don't want to take off too much material. And what I'm going to do here is just work the excess solder back so it's almost flush with the beading. So that's now probably about a quarter of a mil outstanding now. I'll work on the top section now. Right, it's pretty much flush on the top now. I'm just going to use the sanding stick just to get into the corner here. So you can see already now from the top, we've essentially repaired this piece. Now I'm going to go back and get it flush on the side. So we're now flush on that side, so from the top it's essentially repaired. And we just have this little section here to sort out. And for that I just use my curved Swan Morton scalpel blade. It's a brand new blade, so it's very sharp. Use a rocking sort of action backwards and forwards and just line up the blade underneath the beading and just rock slowly backwards and forwards, making a cut into the solder. And if you leave yourself a little bit of room for error, it makes it a lot easier. Now I slice up from the underside. Again in from the top. And in from underneath. And there we are. All we need to do now is clean that up and we've repaired our beading. So pretty much the final job on this build is attaching the top of the tender to the base of the tender, and in order to do that I've already cleaned this up really well inside, and I hope you can see, but I've run a very thin tinning of solder all the way around the inside of the brass bit there. That's with 145 solder, very thin layer just inside the tender there, just to help the white metal solder stick to it properly. And then on the white metal part itself then I've just cleaned up the ridge really nicely, and we'll now apply some solder to that. Alright, the iron's on at 200 Celsius. Pick up a small amount of white metal solder. And simply run a small amount of it up into the joint area, like that. We've now got a line of low mount solder all the way around that, and we can now move on to joining them together. we're going to do is just grab the main tender piece here and just run a small amount of flux just on the inside of that. Now, we must remember to wash this immediately after we've done, because otherwise the flux will start to oxidize the brass, but it's okay at the moment. You just pop this on, and it's going to be a tight fit, but what we're going to do now is turn the iron up. So we're at 300 degrees now, and here we're just going to work the iron along the outside like so, and if you imagine on the inside what's happening is that that low melt solder is melting, and it's sticking the two parts together. So for the purposes of this video then, I'm calling this tender completed. Now, I've shown you the vast majority of the techniques that we need to build it. I think, or I hope that I've shown that it's relatively straightforward, and what you end up with is a lovely, solid, personally built tender, which I think is absolutely fantastic. All we need to do is attach this sort of guardrail onto the top of the tender and a couple of other small bits and bobs, but essentially this is done now. I hope you've enjoyed it. I hope it's given you some inspiration to maybe get onto the workbench over the Christmas period if you've got a bit of time, but in the meantime, enjoy your modelling, and I'll see you again soon. Thanks for watching. Bye bye.